Okay, welcome back. This is the test 4 review video for our fourth final test, and then we'll have a final exam, which I usually just base off the in-class tests. So to review for the final exam, I would recommend going back and making corrections to your old tests, finding similar problems in the book, and I'll talk more about that once we should have a day for talking about the review for the final. Anyways, let's dive right in. So in the first section, 11.1, we have the square root property. I will tell you which property I want you to use, and so you'll know on the test. Okay, so please read direction. Okay, so anyways, the question pool for 11.1, 1 to 57 odd, questions like that. And okay, so the first kind of problems, a square root property. There's also completing the square in here, but square root property first. So solve using square root property. Okay, so number 5 here, we have 16x squared equals 25. So first you want to isolate the x squared part. Get this all by itself. So divide both sides by 16. I get x squared is 25 over 16. Square root on both sides. X is plus or minus square root of 25/16. You could simplify that pretty easily then. Please rationalize denominators, that sort of thing. 5/4. Sorry. Plus or minus 5/4 would be your answer. Let's look at number 7. So we got 3x squared minus 2 is 0. Okay, so again, you need to isolate the x squared part. So add 2 to both sides. Divide both sides by 3. And then square root property, x equals plus or minus square root of 2/3. I need to rationalize a bit. So I need to go top and bottom by root 3. And that'll give me x equals plus or minus square root of, whoops, so there's a square root 6 up top. In the bottom you have square root 9, which of course is just 3. Okay, so rationalize denominators for me. The next section is completing the square. So solve by completing the square. And the magic number that will do it is b over 2 squared, so you have to have that number memorized. And the way it works is kind of first get all the variable stuff on one side, all the constant stuff on the other. Make sure you have a leading coefficient of 1 on the x squared, and then add b over 2 squared to both sides. Okay, so here I got to move the 1 over. B is 3 in this case, 3 over 2, and then squared, so I get 9/4, so I have to add that to both sides. That's completing the square. On the other side, I have 1, so let's rewrite 1 as 4/4, so it already has a common denominator. Then we can factor this guy, so you get x plus 9/4, so 3 halves, so you basically just take the square root of 9/4. 3 halves squared, and on this side you'll have 13/4. And then you can use the square root property to solve. So you get x plus 3 halves equals plus or minus square root 13/4. I'm going to move the 3 halves over, so x is 3 halves plus or minus square root 13 over square root 4. Square root 4 is just 2, so we get that expression for our final answer. Oops, I lost a negative on the 3 halves. Let's try 45. So I have x squared plus 4/7 x plus 3/49 equals 0. Okay, so move the 3/49 over. Second step, 4/7 divided by 2 is the same as 4/7 times 1/2. Then I got to square it. What is this? 2/7. And square it. That'll be 4/49. And I got to add that to both sides to complete the square. So x squared plus 47x plus 4/49 equals negative 3/49 plus 4/49. Okay. Factor, so I get x plus 2/7 squared. The other side you get 1/49. And then finally square root property, x plus 2/7 equals plus or minus square root of 1 over 49. And then finally move the 2/7 over. So negative 2/7 plus or minus square root of 1 is 1. Square root of 49 is just 7. Okay, so we can simplify our answer. So x is negative 2/7 plus 1/7. That'll be negative 1/7. Or x is negative 2/7 minus 1/7, which is minus 3/7. Okay, so two answers there. Let's do another. 51, we got 3x squared plus 6x plus 1 equals 0. Okay, so for this guy, you need that leading coefficient to be 1. I'm going to move the 1 to the other side first. 3x squared plus 6x equals negative 1. And again, what do I need? I need this thing to be a 1. Okay, that leading coefficient on the x squared, I need it to be a 1. So what do? Multiply both sides by 1/3, which is the same as dividing everything by 3. Okay. So you'll have x squared plus 2x equals negative 1/3. And then we can complete the square and all that jazz. So I'll have b, this time is 2 over 2 squared. 2 over 2 is 1. 1 squared is 1. Add that to both sides. Factor. That's 1 squared. And the other side, 1 is the same as 3 over 3. So 3 over 3 minus 1 over 3 is 2 over 3. Square root property, I get x plus 1 equals plus or minus square root of 2/3. Okay. Move the 1 over. I'm going to have to rationalize this thing, so the square root of 3 on top and bottom should do it. But anyways, we got negative 1 plus or minus the square root of, whoops, I rationalized. And the numerator has square root 6, and the denominator square root 9, which of course is just 3. So negative 1 plus or minus root 6 over 3. Imaginary numbers are good here. If you run into a square root of a negative, you're going to replace it with an I. So here we have 2x squared minus 5x plus 7 equals 0. So I'm going to move the 7 over. And I see I have an issue with the leading coefficient, so I'm going to multiply both sides by 1/2. In other words, divide everything by 2. The b value is negative 5/2. Negative 5/2 divided by 2 is the same as negative 5/2 times 1/2. Square that. So negative 5/4 squared. In other words, 25/16. I have to add that to both sides. I'll need a common denominator eventually, so I'm going to multiply top and bottom of this thing by 8 to make that happen. Okay, so on the left I have x squared minus 5/2 x plus 25/16. On the right side you'll have negative 56/16 plus 25/16. Factor. So the x plus 5/4 squared equals, that looks like 31, negative 31/16. Okay, square root property now. So x plus 5/4 equals plus or minus square root of negative 31/16. Okay. Move the 5/4 over. Plus or minus, march the negative out the back door, so that will result in an I. Then you'll have root 31 over root 16. Root 16 is just 4. And that's the standard form for a complex number, a plus bi. Okay. Okay. So make sure you can handle that stuff. 11.2, we get the quadratic formula, which everybody needs to have memorized. Questions 1 to 17, and then 31 to 41. And usually odd problems. Let's look at number 9. So we got 6x squared equals 2x plus 1. Okay, so to work these, you need to get it set equal to 0. So 6x squared minus 2x minus 1 is 0. Then you can identify your a, b, and c. Okay. And then we just plug it into the quadratic. So x will equal negative b, negative negative 2 is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times a times c, all over 2 times 6 is 12. So we get 2 plus or minus the square root of, this will be 4 negative negatives plus 24, so over 12. Will be 2 plus or minus the square root of 28, over 12. 2 plus or minus 28 is really 4 times 7. So I can march out the square root 4 is really 2, so 2 plus or minus 2 square root 7. And then you have to reduce these, so we can factor out a common factor of 2 from the numerator. 7, 12. 2 over 12 is the same as 1 over 6. So I just get 1 plus or minus root 7 all over 6. Okay. Let's get another one. So again, you can have imaginary solutions. 4x squared minus 3x equals negative 6. Let's get everything on one side. So 4x squared minus 3x plus 6 is 0. Get your a, b, and c values. And then plug and chug. So x is negative negative 3 is 3, plus or minus the square root of b squared is 9, minus 4 times a times c, all over 2 times a, which is 8. So you have 3 plus or minus the square root of 9 minus 24 times 4, 6, carry 1, 96, over 8. This will be 3 plus or minus the square root of negative 87 all over 8. March that negative sign out the back of the square root. So I get I over 8. And then because it's imaginary, we have to put it in the complex form. So you can't leave it like this. You have to butterfly it. Okay? You can always butterfly if you want, like that last answer. If you wanted to, you could write it as 1/6 plus or minus root 7 over 6. That way you don't forget to put complex numbers into this form. 3/8 plus or minus square root of 87 over 8i. Okay, so it has to be in that a plus bi form for us. Let's get another. So 13, this one's kind of already set up for us. X squared minus 4x plus 8 is 0. So a is 1. B is negative 4, C is 8. Okay, so x is negative negative 4 is 4, plus or minus the square root of negative 4 squared is 16, minus 4 times a times c, all over 2 times a. So we get 4 plus or minus square root of 16 minus 32, all over 2. So 4 plus or minus square root of negative 16, all over 2. 4 plus or minus square, put the imaginary number out the back, and you get square root of 16. Square root of 16 is 4. So 4i over 2. And then you want to butterfly that one. So you get 4 halves plus or minus 4 halves I. And simplify, that's 2 plus or minus 2i. So get one more that has some fractions involved. Squared over 2. So you don't want to put fractions into the quadratic formula. What you want to do is multiply by the least common denominator of the fractions in the equation in order to get rid of them. Okay, so in this case 6 on both sides should do the trick. Okay, so distributing 6 times x squared over 2 will give you 3x squared. 6 times 2x is plus 12x. 6 times 2/3 will be 12/3, which is 4. 0 times anything is 0. Okay, so we got our A value is 3, our B is 12, and our C is 4. So x will be negative B, so negative 12 plus or minus the square root of B squared is 144 minus 4 times A times C. All over 2 times A is 6. So negative 12 plus or minus the square root of 144 minus 4 times 12 is 48 over 6. So negative 12 plus or minus the square root of 44 minus 48, 96 over 6. You can factor 96 into 16 times 6, I believe. 6, then we can march out a 4. Plus or minus 4 root 6 over 6. And then if you want, you can butterfly or you can factor to simplify. Let's just butterfly it. So negative 12, 6 plus or minus 4, 6 root 6. So we get negative 12 over 6 is negative 2, plus or minus 2/3 root 6, or 2 root 6 over 3 if you wish. Okay. And that'll pretty much do it for that section. Okay, the next section was on graphing. Okay. 11.3, I'm looking at problems like 9 to 37. In particular with the graphing, the way I want you to do it is first find A and describe the graph. Okay. Secondly, then find the vertex. Thirdly, get the x and y intercepts. And then fourthly, graph it. Okay, so I know in the video and in probably in the homework, they wanted you to find the domain, the range, the axis of symmetry. We'll skip that stuff. You'll have to do it in college algebra once you take that class, if you take that. So let's not beat the horse to death. Let's just focus on those 4 things, okay? Okay, so there's 2 forms in the book. There was the kind of the vertex form, which looks like this. And then there was like the ax squared plus bx plus c. So here, the a value is whatever's in front of the x minus 1 squared thing. So it's just 1. It's positive, it's greater than 0, therefore it's a happy face. Okay, so that's what I mean by find a and describe it. So it's U-shaped up, they call it concave up, or you just draw the picture happy face. Okay, but just like that is fine. Secondly, then for these kind, you can read the variable or the vertex right off the function. So it would be 1, 2. So opposite sign for the thing inside the x minus 1 squared here. So instead of negative 1, you get positive 1. And then same sign for the other value. So if it's plus 2, you get plus 2 here. Then we want to get the x and y intercepts. So for the x-intercept, you let y equal 0. So 0 is x minus 1 squared plus 2. Move the 2 to the other side, so get x minus 1 squared equals negative 2. Square root property, x minus 1 equals plus or minus square root negative 2. As soon as you get an imaginary number, you're kind of done, right? If you move the 1 over, plus or minus square root 2i, there's no intercept. We're not plotting in the imaginary plane. We only have the xy plane. So there's no x-intercept in particular. Okay. Then for the y-intercept, you always let x equal 0. So we have y equals 0 minus 1 squared plus 2. So y will be negative 1 squared is 1 plus 2. That'll be 3. So the y-intercept is at 0, 3. Right? And that should be enough to graph it. Then you come over here and graph it. So 1, 2, 3 is the y-intercept. The vertex is at 1, 2. So 1 and then 2. And then it'll be happy face. And of course, there's the axis of symmetry. And it should look exactly the same on the other side. And so it's going to go through that point and then up that. Okay? Okay. Let's look at a couple more of these. So probably 2 of each on the test. 2 of this form, and then the f of x equals ax squared plus bx plus c form as well. And so these will be worth a little bit more because there's more to do with them. Okay, so here we are again. Let's rewrite it so it looks more familiar, and we can see what the a term is. So in this case, the a is -1, which is less than 0, which tells me I have a sad face. The vertex then is opposite sign of -1 is +1, and same sign for the +4, so +4. Then the x-intercept. For the x-intercept, you let y equal 0. So 0 equals 4 minus x minus 1 squared. Move the x minus 1 squared to the other side. The positive x minus 1 squared equals 4. Square root property, x minus 1 equals plus or minus square root of 4. Square root of 4 is just 2. Add the 1 over, so 1 plus or minus 2. So I get x equals 1 plus 2 is 3. So 1 coordinate 3, 0. And then 1 minus 2 is -1, 1, 0. For the y-intercept, you let let x equal 0. So you get y equals -0 minus 1 squared plus 4. So y is -1 squared plus 4. Negative 1 squared is just +1. There's that negative in front, so it's -1. And then -1 plus 4 is 3. So our y coordinate is 0, 3. And we should be able to plot all this stuff. So 1, 1, 2, 3, 4. So vertex 0, 3 is a y-intercept. -1, 0, and then 1, 2, 3, the other guy. Should be going a sad face, and then the axis of symmetry is right here. Okay. Okay, let's look at the other form. So problem 30, f of x equals 2x squared minus 7x minus 4. Okay, so the a value is 2. It's greater than 0, which tells me it is a happy face. Secondly, now the vertex is a little more work. So the x-coordinate, which we call h, is -b over 2a. So -7 over 2 times 2 is 4. So here we have 7/4. For graphing, I'm going to get the decimal 1.75. Okay? Then I need to take that and plug it into my original formula. 2 times 7/4 minus 7 times 7/4 minus 4. And you'll get -10.125. Okay. The x-intercept. You let y equals 0. So you get 0 is 2x squared minus 7x minus 4. And you use whatever method you want to find the answer to that. So always try to factor it first. But if you can't factor it, go to the quadratic formula. Okay? So I think that 2x and x, that looks like 4, and this would be minus, and then plus 1, that will work. So 2x plus 1 is 0, 2x is -1, so x is -1/2. So -1/2 comes 0. And then the other one is just 4, only 4, this is 4, 4 comes 0. Y-intercept, a little easier to figure out, right? For the y-intercept, you let x equal 0. So you get 2 times 0 squared is 0. 7 times 0 minus 4. So y will just be -4. So I get 0 minus 4. Okay, then I want to plot all this junk. It's a happy face picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, so 1.75 about right there, and then negative 10.125 around there. 0, 1, 2, 3, 4 for the y-intercept. 1, 2, 3, 4 for one of the x's, and then negative 1/2 for the other. It should look something like this. Oops. And the axis of symmetry is at 1.75. Okay. One more graphing, and then we'll move on. So problem 32, you have f of x equals 5 minus 4x minus x squared. Okay. If you rewrite it in order, minus x squared minus 4x plus 5. Okay, so first the a value is negative 1. Ugh, technically 1 there. Which is less than 0, which tells me it's a sad face. And secondly, the vertex. So again, you have to have negative b over 2a memorized. So h is negative 4, which is 4, all over 2 times negative 1. 4 divided by negative 2 is negative 2. And then you have to plug it back in. So negative 2 squared minus 4 times negative 2 plus 5. That'll be negative 4 plus 8 plus 5, which will be 9. So negative 2, 9 for the vertex. The x-intercept. For the x-intercept, you let y equal 0. And I get a leading coefficient, so add everything to the other side, or multiply both sides by negative 1 if you wish. Hopefully you can factor it, but like I said, sometimes you have to use the quadratic formula. Looks like this one I'll be able to factor. Plus 5 minus 1. So negative 5, so negative 5, 0. And then 1, 0. Then for my y-intercept, for the y-intercept, you let x equal 0. So y is 0 squared minus 4 times 0 plus 5. And it's always just the c value, y will equal, in this case, 5. So the y-intercept is at 0, 5. Okay, and then we should be able to just plot everything. So negative 2, 9 is in the second quadrant. Negative 1, 2, 6, 7, 8, 9. And of course the axis symmetry goes right through the vertex. Negative 5, 0, 1, 2, 3, 4, 5. 1, 0, 1, and then 0, 5, 1, 2, 3, 4, 5. Depending on how well you drew your tick marks, it'll should go through that point. And then it goes through there, and then down through here. Okay, and that should about do it. Okay, so just those 4 things. Identify the a value. If it's negative, it's a sad face. If it's positive, it's a happy face. Secondly, get the vertex, then get the x and y intercepts, and then graph it. Okay. So look at 11.4. So these were quadratic forms, thinking of problems similar to 1 to 31 odd. So let's see, 3. So they look like quadratics, but they're a little bit different. You approach them in the same way. You're going to try to factor them. So usually it would be like x squared minus 11x plus 18. And now in this case we have x to the 4th. So what times what is x to the 4th? So basically x squared times x squared. And then you can try to figure out your, looks like 9 and 2. And then you can set those equal to 0. Square root property. And x is plus or minus 9, square root 9, so plus or minus 3. And then here, x is plus or minus square root 2. So there are 4 answers there. You don't really have to check these or anything, except when you get a square root, like number 7. This would be one of the ones where you would have to check. So again, it's quadratic form, so what times what is x. So basically square root x times square root x. and then it's like plus minus. You want the bigger number to be positive, and then set each equal to 0. And of course, these are radical equations. So I isolate the square root, and then I have to square both sides, and then I have to check the solution. Okay. So here, just check by plugging it into here. So square root of 4, you have to show the check or you don't get full credit. And particularly in this question, one of the answers won't even work, right? So this one doesn't work because this is a false statement. And again, isolate the radical, square both sides, and then check. So square root 1 minus 1 minus 0. Square root 1 is 1. 1 minus 1. So that one's true, that one works, and there it is. Okay. One thing I saw on tests that people were trying to do is to, like here, if I was checking square root of 1 minus 1 equals 0, some people are like adding 1 to both sides. You can't do that. That sort of defeats the purpose of the check. And then 1 equals 1. That's a no-go. You're not allowed to do that because you'll kind of re-engineer the things that went wrong in the first place. So you'll never see whether or not that's really a solution. It's what we're trying to get you away from doing. Okay, so you have to work on the sides separately. You're not allowed to move things over from one side to the other, like adding 1 on both sides. You just almost have to pretend that they're completely separate from each other. You know, you never move anything from here to the other side or vice versa. Okay, so hopefully that makes some sense. The last section is 12. I'm not going to put any 12.5 stuff on there, just 12.1, and in particular graphing is what I want. So I'll ask you to graph something, and then also, in particular, graph with the table. And then I want you to note the domain and range. And if I don't tell you which values to use for your table, just go from like -2 to 2. It seems like a good idea. So f of x is 3 to the x, and here I'm going to do my table, going from -2 to the 2. Okay, so I get 3 to the -2 is the same as 1 over 3 squared, which is 1/9. 3 to the -1 is 1 over 3 to the 1, which of course is 1 over 3. 3 to the 0 is 1. 3 to the 1 is 3. And then 3 squared is 9. We'll plot them. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So -2, it's like 1/9. -1, a little higher. 0, it's 1. 1, it's 3. And then at 2, it goes up to 9. Okay. And that should get super duper close to the x-axis but never touch. And then it kind of looks like a ramp. It just keeps on going up and up forever. Okay. Then you got to identify the domain and range. So the domain is always the same, -infinity to infinity. And then the range will be everything greater than 0. So 0 to infinity. Okay. Okay, and that should do it. So, as usual, thank you for watching, and we'll see you next time.